So, what is your understanding in terms of the origin of the process standards? You mentioned that they, some iteration of them exist in the Common Core standards.
Well, they hadn't existed in the first two drafts that I looked at.
Right. Yeah, but I mean, just the.
And they were starting to appear but they weren't really dominant in that semifinal one in July of 11. But there was this dramatic change between then and what actually finally came out, where these process standards suddenly were absolutely dominant.
But the process standards that exist in Common Core,
they existed as there had been no change in Common Core. That it came out in early 2010, and there's been no change.
Yeah. So what is your understanding as to where what the origin of those process standards are, and what is the intent of them?
Okay. Well. The first time process standards like that appeared was in the 1989 NCTM standards, National Council of Teachers of Mathematics. And the math community, the professional math community was very, very upset by that, because they were focusing in on what we felt were the wrong aspects of learning, and we didn't believe that students would come out of the NCTM approach with the kind of expertise that would be needed at the college level. The automaticity in terms of calculation, for example, was suppressed, and it isn't that it's useful in and of itself, but it's critical in terms of brain research that you realize that once students get into things like calculus and things like that, they do not have the time to count on their fingers or anything like that. That had better be automatic. And so you were getting students who coming out of the NCTM standard style in the 90s who were not remotely automatic and couldn't go on past calculus because they just didn't have the background. So the first thing we did in California in the late 90s when we got rid of NCTM standards and wrote our own, was to get rid of all of that type of thing, all of the kind of thing, the so-called process standards that were present in NCTM. We just got rid of them because we did not think they were helpful. Now they got put back for NCT from NCTM, they got put back in Common Core. And at least they did this. So exactly what the problems were unchanged. They were using the same things. But I had just solved a fairly major problem about that time in protein folding. And so they finally asked me a reasonable question. What was the process? Because after all, protein folding is biology. And I'm a mathematician. So I'm taking my math expertise and applying it. And what was the process that you used, they asked me, to find a result like this in a field that you don't know? So in other words, how does one apply mathematics? What are the processes you go through with to apply it? And so I answered them in great detail, and a lot of that answer appears in the detailed discussion in the Common Core process standards.
So the way I understand it then is that how it was explained to us is that the idea of the process standards was to teach mathematics from a conceptual viewpoint, And for students that we know that, and I spent enough time in the classroom, and I was a teacher, that there are certain students that, you know, naturally tend to have a stronger capacity for mathematical reasoning than are others. And the idea was then is that if you teach it from a conceptual viewpoint where students can really understand these things, and that these process standards would help them to do that. So tell me what is the flaw? I mean, and what I'm hearing is that there is a flaw in that line of reasoning. And can you tell me what that is?
I can, of course, but there is I'd hate, you know, it would take quite a while, and
give me the Reader's Digest version.
Oh, let me think about it for a second here. Okay, first thing one needs to know is a certain amount of study of these things has been done. A lot of those studies have never been published because what they showed was that the change in outcomes for students in terms of their ability to do basic mathematics were unchanged at best. And a lot of them showed that on average they got worse. But they were never published for the simple reason that, well, if you've been a teacher, you are probably aware of the selectivity of the ed school journals. So in point of fact, there really isn't any research that shows these things do what they say they're going to do. Now you look at something else, which doesn't obviously appear to be connected, but it is. And you look at the high achieving countries like Korea or the developed areas of China or Hong Kong, you know, Singapore. All of these areas that really get remarkable results, and you ask, well, what about the kids, the weaker kids, the ones you were talking about originally, the ones that need remediation? And they look at you and they say, what? They don't have that problem. Their kids don't need remediation. They learn this stuff because they learn it in a totally different way than we teach it. They learn it from a modern perspective of mathematics. We are teaching it the same way it was taught 2,000 years ago. And the people in the high achieving countries are teaching it the way we did develop the thing in the new development of foundations for mathematics between about 1880 and 1920. So over that period of 40 years, we changed our perspectives on almost everything in the foundations, and that's what these kids are learning today in the high achieving country, and that's how they're learning. And it makes it so much cleaner that there will be problems. I mean, there are differences in ability, there just are, but they don't appear through grade 8. They simply don't appear.
And so what you're telling me is that using the process standards, whether they be in the Texas standards or the Common Core, is not consistent with brain research in terms of how students learn math.
That's among the things, yes.
All right, thank you.